Assalamu alaikum and have a good day. So we are in chapter 2, Information Technology. Last week we discussed hardware and software, and today inshallah we will complete data resource management and telecommunication and network. First, data resource management. Data resource management, data administration or data resource management is an organizational function working in the area of information system and computer science that plans, organize, describe, and control data resource. And if we study this chapter, we will be understand the management of the data resource and computer using organizations and understand the key data management concept and application in business information. So if we see here data resource management and data, and basically here within this chapter we will be able to understand database management, fundamental data concept, database structure, and database development, and also managing data resource through the data management system, types of data, data warehouse and data mining, traditional file processing, and the database management approach. So this is the learning thing in our within the chapter. Database management, also we know it is as we are calling DBMS. So a database management system is a system software for creating and managing database. So this is the basic definition, and the database provides user and programs with a systematic way to create, retrieve, update, and manage data. So if you see this picture, database management system here using the application, other database management system, use the user here, database management system. Now look here, define, record, query, update, manage within the server, and storage area in here in the server. Within the support server, relate that means rational database, recreated database, flat file database, object database, part of the database, and make a big database. So here database management system is the fundamental data concept, or a conceptual framework of several level of data has been derived, and that means different among the different group and element of data. We can design it in different group, different element, different, like look here rational database, flat database, object database, different this way. So thus data may logically organize into character, fields, records, files, and database. This is the component, and we know it just as writing can be organized into letters, words, sentence, paragraph, and document. Just using the letter, we are making a word, and more than one word, it's go for the sentence, and more than one sentence make a paragraph. Same way, data, character, field, record, files, and database. So this way we can make the database. So example of logical data element here, human resource database or HR database or payroll database. Here benefit file, payroll file, employees all record based on their code, everything all within that database. So it is the data may be logically organized into. So here first character, then field, then record, then file, and finally database. So it is the logical data, that means data may be logically organized. This way we can organize data. So we will discuss this one: character, field, record, file, and database. So now character. The most basic logical data element is the character, which consists of a single alphabetic, numeric, or other symbol. So we may argue the bit or byte is maybe elementary data element, but we have to remember those terms refers to the physical storage element provided by the computer hardware. And we know it, bit, we know, is the binary digit, we know it, 0 or 1. And also we know that 8 bits make a byte. So each letter of a small number of 8, that means 0 and 1, is make a byte. So here bit, byte, look here, this 8 item makes a byte, but one single is a bit. Terms for storage capacity, and storage capacity, we know capacity of data storing, and also we know 1 bit, that means we call it B, 0 or 1, 8B, 1 byte, 1000 byte equal to 1 kilobyte, 1 million byte is 1 megabyte, 1 billion byte is 1 gigabyte, GB, 1 trillion byte is 1 terabyte. So this is the term storage capacity. Binary arithmetic. So from the binary number, how we can calculate an arithmetic number. So if this is the number, look here, 110110001 is the binary. We know the binary digit is 0 and 1. So based on that place, for example, here 1 equal to first, that's 1 multiply by 2 base 2, that means binary base is 0. So here is 1. So this way, last one, if we see here first one, but here last one, this 1, that means 2 to the power 7, because 1, 2, 3, 4, 5, 6, 7. So it's come 128. So adding all data, here we get 217. So this number we can convert is the arithmetic, that means 217. Though we do not need to memorize that thing, but for understanding. And what is field? Firstly, here we have seen character, and now field. A field, that is the next level of data, is field. A field consists of grouping of related character. So a field consists of a grouping of related character. And here the grouping of alphabetic character in a person name made from the name field, etc., first name, last name, middle name, etc., and the group, that means father's name, parent's name, or spouse name, etc., within a group. So here an employee's salary is an attribute that the typical data field used to describe an entity who is an employee of business. So it's the field, and fields are organized such that they represent some logical order. For example, last name, first name or middle name, address, city, state, zip, etc. And record, all of the fields that we describe used to describe an attribute of the entity are grouping from a record. Thus, a record represent a collection of attributes and describe a single instant of an entity. And that one person, payroll, record, which consist of data field describing attributes such as the person name, national ID number. We can say here no need for social, NID, and 18, etc. And rate of pay, etc. So it is the unique. record individual, and this unique identifier called the primary key. The value of the primary key can be anything that will serve to uniquely identify one instant of any entity and distinguish it from another. Here, if you see product ID or employee ID, here number 1, 2, 3, 4 is the part of primary key. Here, participation key. Here, short key, ID, and product. If you see is the product, so is the product ID, which product is, and which type of the product, and product attribute schema of different part, that means it can be segregated in different part. So here is saying that if we want to uniquely identify a single student or product from a group of the related student or product, we could use a student ID number. For example, in your at this moment your roll number, and also we are the member, our enrollment number. So this is the unique number. As long as no one shared the same ID, we would always be able to identify the record of that person. If no specific data can be found to serve as a primary key for a record, the database designer can simply assign to record a unique sequential number so that no two records will ever have the same primary key. So here saying that all have the unique number. For example, our national ID, our TIN number, our enrollment number, all are the unique. So now file. A group of related record is a data file. Sometimes refers to as a table or flat file. So we can say a group of related records is a data file. When it is dependent on any other file related to it, a single table may be referred to as the flat file. Sometimes, for example, in Excel file, we are using the link. For example, if you want to create, that means prepare a financial statement of a company, and all data from the balance sheet to P&L and other data, you go to the that means cash flow and other, all are interlinked. So that file is the that plot file, also that is independent of any other file related to it, is a single table, may be referred as a flat file. As a point of accuracy, the terms flat file may be defined either narrowly or more broadly. Strictly speaking, it flat file database should consist of nothing but data and the element. So the file, and finally database. A database is an integrated collection of logically related data elements. A database consolidates record previously stored in separate file into a common pool of data elementary that provides data for many applications. The data storage in a database are independent of the application programs using terms and to the types of storage device on which they are stored. If we see this picture, look here, it's saying that some of the entity and relationship in a specified electronic unity database. Note a few of the business application that access the data in the database. Here saying that is the electricity utility database. So here for our electric authority, how they process bill, how they that we submit bill, how they update their database. It's a big database here. Entity, that means customer, we are user, and meter, number of meter, because all customer in our house and your everywhere, the meter, electric meter is that the meter is the unique number, and within that entity where require customer, meter, bills, payment, meter readings, uh, etc. And a relationship that's bill sent to the customer make payment, customer use meter. So this is the logical relation. So within this database comes bill, and after, for example, here taking the meter reading, process the bill, and that bill goes to the customer pay the bill. After processing or database update, service start or stop here, and electric database saying this way. So that type everywhere in our office, our if you the audit software, all database within a software, with a system, within a server, same HR, that is payroll and HR software, taking all data, HR related, their salaries, overtime, their information, their performance, annual performance, everything within that database. So database structure, the relationship among the many individual data element stored in database are based on the one several logical data structure models. And database management system, DBMS, is the package designed to use a specific data structure to provide end user with quick, easy access to information stored in database. So this is the fundamental logic. Easily can be accessed. Who want it? That is definitely the authorized person. So there are 5 fundamental database structure. One is hierarchical, network, rational, object-oriented, and multidimensional model. So this is the 5 database structure. So hierarchical model is that, and we know it is the organizational pattern. So if a department data element is can be project 1, 2, and within that project 1 it can be segregate different. So this structure is a hierarchical database. Example of fundamental and hierarchical database is a design that use a one to many relationship for data element. This database model use a tree structure that link to number of this separate element to one owners or parent primary record. And if we see this is what heritage database model, network model. So this is the network structure. This way interrelated one to another. And rational structure. So here a database, we know it, a database that can be perceived as a set of table and manipulated in accordance with the relation model of data. Each database includes a set of system category table that describe the logical and physical structure of a data. So here, rational structure, look here, this if this database is a department, and there are different department or different segment also, and within that department there are employees table that employee related within the department. So employee 1, employee 2, they are the in different department, but this is the structure table. There's employees tables and departmental tables is other interrelated. The relation with that one structure to another structure. And here, look here, is saying that joining the employees and department table in a relational database enable us to access data selectively in both table at the same time. So here, look here, department table and employee table. If you That means want to go for this department data that is interrelated with the employees table, employee data. If you also put that department, it also comes to that employees. So it is the interrelated and but separate table, but all data within the same server. What is network database system? Network database, a database that runs in a server in a network that is available to authorized user. So here important thing is authorized user. Authorized user, that person who who has given the permission for access the data, because he have the a specific user ID or password for entering for using that data. So database that runs in a server in the network and is available to authorized user. Say database of network user address, address organized method that allow for data relationship in a net-like form. So here, object-oriented database. An object-oriented is a database management system in which information is represented in the form of object as used in object. And object-oriented program and object database are different from the relational database, which are table-oriented. Here, if we go see our bank account object, here customer's balance, customer interest, it is the total part of the database. An operation that is some deposit, withdraw, owner, etc. As here, if for we are putting our ATM card, our card to in our ATM machine, that what's calling here checking account objective. That means first that input go to the server and checking that the password is if correct, then take the necessary next steps and check the balance of that account. And the authorized, because authorized is there because he's putting the specific password, that password that is given to the customer, and the owner of that password is the customer. And logically that account query go to the server and checking that how much money and ATM card holder wants to withdraw or sometimes can be deposit is basically object oriented. Object oriented here meaning that for example, we want to deposit money, then have to check that is if we digitally want to digital money, then we have to put our specific password and clearly, and if password is correct, then next steps can be happen because we can deposit through our accurate account, and also same way we can be withdraw money from our account and balance would be available. So this can be object oriented. And what is object oriented database? And we have to, if we see the example here, so object oriented database is that an object oriented database is organized around object rather than action, and data rather than logic. For example, a multimedia record in a relational database can be a definable data object as opposed to an alphabetical value. So it is saying that an object-oriented database is organized around the object that rather than action, and data rather than logic. A database object is a defined object in a database that is used to store or reference data. Some example of database object include table, view, cluster, sequence, index, etc. The table is the hours focus because of the primary and simplest from the data storage in a relational database. What are the four objects of a data? So database object And if we see the database access 2010 are compared to the 4 objects here: table, queries, forms, and reports. So this is the 4 objects. One is table, second is queries, and third is forms, fourth is report. So this is the objects of database. And multidimensional database model is designed to solve complex query in real time and is composed to logical queue, meters, diamonds, hierarchy, level, and attribute. The simplicity of the model is to inherent because it defines object that present real world business entity. Here an example of different dimension of multi-dimensional database. Here one person, that means if the separate office or subsidiary company, and look here in the month base actual budget, in the product base sale or margin, each and every product here within this database is a multi-dimensional database model. So different way, the multi-dimensionally can be take the data, within the data can be take different types of report. That type report helps to management for decision making. What is multidimensional database example? A multidimensional database, we can say that MDB is a type of database that is optimized for data warehouse and online analytical processing. So here is the online analytical processing application. An online analytical processing application is that application that accesses data for a multidimensional data known as multidimensional online application database application. So evaluation of the database structure, if you see here, the hierarchical data structure was a natural model for the database use, for the structure, routine, type, transaction processing character of many business operation in the early years of data processing and computing. Data for this operation can easily be represented by groups of records in different way. However, look here, evolution of database structure, hierarchical, network, and relational. So we discuss there. And database development. Database application development is the process of obtaining real-world requirement, analyzing requirement, designing the data and function of the system, and then implement the operation in system. So here saying that database application development is the process of obtaining real-world requirement, what we necessary, and analyzing requirement, designing the data and functions of the system, and then implementing the operation in the system. So database management package, we know they are Microsoft Access, Lotus approach, etc. is here. So here database administrators, large database use, handle of database administration. So that type also job position is also that way, data analyst, data administrator, data security officer, as like our security officer also, data security officer also another post. So data definition language use, database development use the data definition language DDL in database management system like Oracle, IBM, etc. So here the data development life cycle. So if see here, requirement analysis first we have to analyze the requirement, then we have to design data base, we have to design data, that database design and evaluation and selection, which one we will select, logical table design, physical database design and implementation of database and data loading within the system and testing and performance tuning and data operation and maintain, and this way growth of database and change the database based on the requirement. A data dictionary is a database management catalog or dictionary containing metadata. So what is data dictionary? So data dictionary is a database management catalog or directory containing metadata. So what is metadata? Metadata is data about data. So this is the type of question, our that is objective question. Data dictionary, metadata or data about data. A data dictionary relies on a specialized database software component to manage a database of data definition, which is metadata about the structure, data element, and other characteristic of an organization database. For example, here, look here. Here the is taking from the Oracle. So new data dictionary. Here the architecture, queries, query. Here is the data dictionary. External API, that means include with the API, and data dictionary internal API, data dictionary table space. It is taking from the Oracle. So is the Oracle database dictionary and database development. Thank you all, and we'll see you again next week. Allah Hafiz.
Okay, sir. Assalamu alaikum.